In the middle of the Atlantic Ocean, there is a sea with no shores at all. A sea bounded only by four great currents, and for centuries, sailors swore it was where ships went to die. They called it the Sargasso Sea, and they said it swallowed vessels whole, leaving them adrift forever with no crew aboard. For years, NOAA Oceanographers studied the reports, the logbooks, and the wreckage, and what they found was stranger than any legend. Because the truth was not supernatural at all. It was written in the physics of wind and water. Picture a wooden ship in the age of sail, her canvas hanging limp, her crew staring at a horizon that never changes. This is the doldrums, the windless heart of the Sargasso Sea, where the trade winds simply die. Ships entering this region could sit motionless for weeks, sometimes months, their food and water running out long before any breeze returned. Sailors who survived called it the horse latitudes because desperate crews were said to throw their horses overboard just to save fresh water. Those who did not survive became the ghost ships whispered about in ports from Lisbon to Havana. NOAA researchers poring over centuries of maritime records found pattern after pattern. Vessels reported abandoned with sails still set, tables still laid for dinner, cargo untouched, yet not a single soul aboard. No storm damage, no signs of piracy, no explanation that made sense to the sailors who found them. But oceanographers looking at the currents saw something else entirely. A sea that behaves unlike any other on Earth. A sea with no coastline to anchor it, defined only by moving water. The Sargasso Sea sits inside the North Atlantic Gyre, held in place by the Gulf Stream to the west, the North Atlantic Current to the north, the Canary Current to the east, and the North Atlantic Equatorial Current to the south. These four currents rotate clockwise, slowly pulling everything toward the calm center, like water circling a drain in impossibly slow motion. A ship caught in the outer currents could be swept for weeks before ever reaching land, its crew long gone, its hull eventually drifting into the becalmed interior where the wind refused to blow. Golden brown mats of sargassum float across the surface for hundreds of miles, dense enough in places to actually slow a ship's progress. Early explorers described sailing through fields of floating gold that stretched to the horizon in every direction. Some believed the weed itself could trap a vessel, wrapping around the hull, tangling the rudder, holding ships captive in a floating meadow with no wind to escape it. NOAA scientists confirmed that sargassum mats, while not strong enough to physically hold a modern ship, absolutely could slow small sailing vessels and disorient crews who lost sight of open water in every direction. For decades, this sea earned a reputation as a maritime graveyard, blamed for disappearances that overlapped with tales of the nearby Bermuda Triangle. But NOAA oceanographers wanted data, not folklore. They deployed drifting buoys equipped with satellite transmitters, releasing them into the gyre to track exactly how water moves through this strange, borderless sea. What they discovered reshaped everything sailors thought they knew. The buoys revealed that objects entering the Sargasso Sea do not simply vanish, they circulate. Debris, driftwood, and yes, abandoned vessels get caught in a slow clockwise rotation that can take a year or more to complete a single loop. A derelict ship found floating hundreds of miles from where it was last seen was not proof of something paranormal. It was proof of ocean physics, playing out over months of drift. Researchers matched debris fields to storm dates from years earlier, tracing exactly how long it takes wreckage to travel from the outer Atlantic into the becalmed Sargasso interior. Modern satellite imagery gave NOAA oceanographers a view no sailor of the past could have imagined. From space, the Sargassum Belt appears as a golden ribbon stretching across the Atlantic. sometimes visible from the Gulf of Mexico all the way to West Africa. Scientists began measuring its size year over year, and the numbers stunned them. Since around 2011, the sargassum bloom has grown far beyond its historical range, forming what researchers now call the Great Atlantic Sargassum Belt, a mass of floating algae so large it can be tracked continuously from orbit. This explosive growth transformed a regional curiosity into a global concern. Massive rafts of sargassum now wash onto beaches across the Caribbean, Florida, and Mexico, sometimes piling several feet deep and releasing hydrogen sulfide as they rot, a smell so strong it has driven tourists away from entire coastlines. NOAA researchers began asking a new question. Not why ships got trapped centuries ago, but why this ancient sea is behaving so differently now. Runoff from major rivers, shifting wind patterns, and warming surface waters appear to be feeding sargassum growth on an unprecedented scale. What once floated as scattered patches, thick enough to slow a becalmed sailing ship, has become a continuous belt, spanning thousands of miles. Oceanographers studying satellite data now track this belt the way meteorologists track a hurricane, issuing seasonal forecasts for coastal communities, bracing for the next wave of golden seaweed. But the Sargasso Sea was never only a place of danger. NOAA scientists describe it as one of the most unique ecosystems on the planet, a floating nursery where sargassum mats shelter juvenile sea turtles, eels, crabs, and fish found nowhere else on Earth. European and American eels famously travel thousands of miles just to spawn in these waters, a migration so mysterious it took researchers generations to even confirm where eel larvae were being born. The very sea that swallowed ships also gave life to entire species that depend on its calm, drifting waters to survive their first fragile months. NOAA oceanographers point to a combination of factors that fed the legend without needing anything supernatural at all. Crews abandoned ship during storms on the sea's turbulent edges, launching lifeboats that never made it to shore, while the empty vessel drifted on, undamaged, into the becalmed center. Disease could sweep through a ship trapped for weeks without wind, killing or driving off survivors long before land was ever sighted. Some crews, driven to desperation by dwindling supplies, simply mutinied or fled, leaving cargo and belongings exactly as they were. Every element sailors once blamed on curses, sea monsters, or vanishing forces turns out to have a physical explanation once you understand how this sea works. No consistent wind to fill a sail. Currents that circle for months without releasing what they capture. A floating seaweed so dense it can disorient a small crew searching for open water. Combine those forces and the Sargasso Sea becomes exactly what it always was. Not a supernatural graveyard, but the strangest, calmest, most isolating stretch of ocean on the entire planet. The same tools that finally explained centuries of maritime mystery are now being used to predict where the next massive bloom will wash ashore. The ghost ships may belong to history, but the sea that created their legend is more active, more studied, and more consequential than it has ever been. And perhaps that is the real revelation buried in NOAA's decades of research. The Sargasso Sea was never empty, never cursed, never a void where ships simply disappeared. It was always full of currents circling in patient rotation, full of golden weed sheltering hidden ecosystems, full of physical forces powerful enough to trap sailing ships for weeks and still calm enough to nurse fragile new life. What remained, once the science caught up with the legend, was something far more fascinating than any story sailors ever told in port. Before we go further, imagine standing on the deck of a 19th century merchant ship, days after the wind first failed. The ocean around you is glass, mirror flat, stretching to every horizon without a single ripple. Sailors called this the doldrums for a reason, because that flat calm did not just stall a ship, it stalled the mind. Men who had crossed oceans without fear began to see things in the endless golden weed drifting past the hull. Logbooks from this era describe crews growing paranoid, convinced the sea itself was holding them on purpose, refusing to let go. NOAA Oceanographers digging through archived shipping records found dozens of cases matching the same eerie pattern. A vessel departs a known port, fully crewed, fully provisioned. Weeks pass with no contact. Eventually, another ship stumbles across it, drifting silently within the Sargasso Sea's borders. Sails still rigged, cargo untouched, and absolutely no one aboard. To 19th century sailors, this looked like sorcery. To modern researchers armed with satellite drift models, it looks like something far more explainable. A slow-motion abandonment scattered across weeks, pieced back together by tracing currents backward in time. One of the tools that changed everything was the Argo Float program. Thousands of autonomous instruments scattered across the world's oceans that drift with the current, while recording temperature, salinity, and depth data every few days before surfacing to transmit their findings by satellite. Inside the Sargasso Sea, these floats behave almost exactly like the derelict ships of centuries past, caught in the same clockwise rotation, sometimes taking more than a year to complete a single loop through the gyre. By watching where these floats travel, oceanographers can reconstruct the invisible highways that once carried abandoned vessels for hundreds of miles without a single sail ever catching wind. The story of the eels deserves its own moment because it took science far longer to solve than anyone expected. For centuries, no one had ever seen an American or European eel spawn, not once, in any body of water anywhere on Earth. Fishermen caught adult eels by the thousands, yet the earliest life stage of the species, a tiny transparent larva called a leptocephalus, kept turning up specifically in Sargasso Sea waters and nowhere else. Their offspring then drift for months inside the same gyre that once trapped sailing ships, riding the current back toward the very rivers their parents left behind. NOAA's modern monitoring goes far beyond drifting floats. Satellites equipped with ocean color sensors now scan the Atlantic daily, measuring the exact reflectance of golden sargassum against blue water to estimate bloom size down to the ton. Researchers combine this imagery with wind and current models to forecast weeks in advance which beaches in Florida, Mexico, or the Eastern Caribbean are likely to face the heaviest seaweed landfall. What began as pure curiosity about a mysterious calm sea has become an operational forecasting system, complete with public alerts for coastal communities and tourism boards planning around seasonal sargassum surges. The scale of recent blooms is difficult to overstate. In peak years, researchers have estimated the Great Atlantic Sargassum Belt stretching more than 5,000 miles from the coast of West Africa to the Gulf of Mexico, carrying an estimated total mass in the tens of millions of tons. That is more floating biomass than most people can visualize. An entire golden continent of algae drifting on ocean currents, visible from orbit as a continuous ribbon threading across the Atlantic basin. NOAA scientists compare current bloom volumes against a historical baseline recorded before the early 2010s, when the Sargasso Sea's weed stayed largely confined to its namesake waters instead of spreading basin-wide. Why the sudden explosion? Researchers point to several converging factors rather than one single cause. Increased nutrient runoff from the Amazon and Congo river systems, driven partly by deforestation and fertilizer use, appears to be feeding sargassum growth far beyond its traditional range. Shifts in wind patterns and ocean circulation, some linked to broader changes in Atlantic climate cycles, are allowing weed mats to drift and multiply across a much wider stretch of ocean than the historical Sargasso Sea alone. Warmer surface waters accelerate the algae's growth rate, letting mats double in size faster than coastal cleanup crews can remove them. For the ships of the past, none of this bloom expansion existed yet, but the underlying mechanism was already there in miniature. A relatively small concentrated mass of golden weed was more than enough to disorient a wooden ship with limited visibility and no wind to power through it. Some historical accounts describe crews rowing for days just to break free of a single dense weed field, only to find themselves circled back by the current into water that looked identical to where they started. Without modern navigation, a sailor trapped inside the Sargasso Sea's interior had almost no way to judge distance or direction, since every horizon looked the same, calm, golden, and utterly silent. Modern NOAA research vessels now sail these same waters, not in fear but in fascination, deploying nets to sample sargassum communities, cataloging species of crab, shrimp, and juvenile fish found nowhere else on the planet. Some of these creatures have evolved coloring and camouflage so specific to floating sargassum that scientists consider the entire mat system its own unique biome. A floating rainforest with no roots and no fixed address, drifting wherever the gyre carries it. Sea turtle hatchlings from beaches as far away as Florida and Mexico instinctively swim toward this weed once they enter open water, using it as a nursery that shelters them from predators during their most vulnerable early months. Put all of this together, and the picture that emerges is almost the opposite of the old legend. The Sargasso Sea was never a void that erased ships from existence. It was, and still is, one of the busiest, most biologically rich regions of open ocean anywhere on Earth, simply operating on a time scale and a stillness that 19th century sailors could not comprehend. Ships did not vanish into nothing. They drifted, sometimes for months, carried by currents now mapped in exacting detail by the same kind of instruments NOAA uses to forecast the seaweed blooms threatening coastlines today. The final irony may be this: the very stillness that doomed becalmed sailing ships centuries ago is now threatened by change. Warmer waters, shifting currents, and nutrient pollution are transforming the Sargasso Sea faster than at any point in recorded history, turning a once quiet, isolated body of water into an actively monitored, rapidly evolving system, tracked by satellites, drifting buoys, and research vessels around the clock. The ghosts of the age of sail have long since settled into history. But the sea that created their legend is very much alive, restless, and according to NOAA's own data, changing in ways researchers are still racing to fully understand. There is one more piece of this story that NOAA researchers had to untangle, and it involves the very name of the sea itself. Portuguese sailors, some of the first Europeans to cross this stretch of ocean during the Age of Exploration, named it after the floating weed they saw everywhere, sargasso, because the round air bladders that keep sargassum afloat reminded them of a small grape they knew from home. That single observation, made in wonder rather than fear, eventually curdled into dread as more and more ships reported becoming stuck, surrounded, or simply lost within the same golden fields the Portuguese had first admired. Christopher Columbus himself sailed directly through these waters, and his crew's journals describe both awe and rising panic at the endless weed stretching in every direction. For a crew already anxious about sailing into the unknown, a sea with no coastline, no wind, and no end in sight to the floating gold around them was almost unbearable psychologically. regardless of whether the ship was ever in any real physical danger. NOAA historians studying these early accounts note that fear of the Sargasso Sea likely predates almost any other Atlantic maritime legend. Planted centuries before, steam power made becalming irrelevant, and long before anyone understood the currents responsible. As steam engines replaced sail in the industrial era, the physical danger of becalming faded almost overnight. Yet the legend of the Sargasso Sea only grew stronger, absorbed into broader stories about the nearby Bermuda Triangle. Popular writers blended real historical becalming incidents with unrelated disappearances from entirely different parts of the Atlantic, stitching together a single sprawling mystery that had little basis in the actual geography researchers study today. NOAA scientists have been careful to separate documented physical phenomena, the doldrums, the gyre currents, the dense weed fields, from speculative claims about magnetic anomalies or vanishing aircraft that fall well outside anything the data can support. What makes the real science more compelling than the myth is precisely how measurable everything turns out to be. Oceanographers can now calculate almost to the day how long it takes a piece of debris to travel from the outer edge of the gyre into its becalmed interior, based on decades of drifting buoy data. They can model exactly how far a sailing ship with no wind and no engine would travel under current alone, replaying historical becalming reports against known circulation patterns from the same season and year. In several documented cases, this modeling matched reported drift distances almost perfectly, turning centuries-old ghost stories into confirmed case studies of ocean physics. The Sargasso Sea also holds a place in scientific history as the first sea ever defined purely by currents rather than by any coastline, a detail oceanography students still learn today as a foundational example of dynamic, boundary-free geography. There is no government that claims it, no nation whose shoreline touches it, and no fixed border that stays the same from one year to the next, since the currents that define its edges shift gradually over time. This makes it one of the strangest bodies of water on the planet to study. A sea defined entirely by motion, drifting weed, and the patient rotation of ocean currents that never quite let go of what they capture. Researchers today use this same borderless quality to their advantage, treating the Sargasso Sea as a natural laboratory for studying how debris, nutrients, and even microplastics accumulate in slow-moving ocean gyres worldwide. Because objects entering this gyre tend to circulate rather than disperse, scientists have found unusually high concentrations of marine debris trapped within the same currents that once held wooden ships captive, offering a troubling modern parallel to the old legend. Where sailors once feared losing their ships to this sea, oceanographers now study how the sea itself is slowly accumulating the waste of the modern world, carried in by the same rotating currents responsible for centuries of maritime folklore. Taken together, the history of the Sargasso Sea traces an arc from myth to measurement, from terrified sailors watching their sails hang useless above a mirror-flat ocean, to satellites tracking golden algae from orbit and autonomous floats mapping currents no human eye could ever follow in real time. Every generation that has crossed this strange, coastless sea has come away with a different story, shaped by whatever tools they had to understand it. For centuries, that story was fear. Today, thanks to decades of patient NOAA research, it is something closer to wonder, a recognition that the ocean's stillest, strangest waters were never empty at all, simply waiting quietly for the right instruments to reveal exactly what had been drifting there the entire time.